And then we've got a final experiment. And this one is finding the angle of total internal reflection. Now, you see that as I increase the angle of incidence, my refracted angle got bigger, okay? Eventually, you'll reach an incident angle where you won't have a refracted angle, you will only have total internal reflection. Total internal reflection means that you no longer have a ray that gets refracted here. That ray will strike the backside of my refraction cup, and then it will reflect inside the water. So there is this interface of plastic that we have to think about, but we're going to pretend like this interface of plastic on my refraction cup doesn't exist, and we just have a boundary between air and water, although that's not entirely true. So sometimes you will see additional reflections and refractions that are because of the plastic of the cup itself, but eventually I'm going to reach an angle of incidence much greater than, especially if I get greater than 50 over here, I no longer have a refracted angle, but I start to have reflection. So here I still have a refracted angle for this incident angle, got refraction over here, but as I increase my incident angle, eventually I'll reach an angle where I can no longer get refraction on the backside, I only get reflection on the inside, okay? And it looks like I've certainly gotten there, okay? And it's a little bit hard, this one, because of all that plastic, but find the angle where at least you can no longer see refraction, okay? And that's your experimental angle for total internal reflection, where the incident angle is totally reflected, or the incident ray is totally reflected inside the medium rather than being refracted.